earlier we did the binomial distribution and the geometric distribution, which were related to discrete data. Now the normal distribution is for continuous data. Also the data should be symmetric. And lastly, because it's symmetric, so the mean is equal to the median is equal to the mode. So this is why when we draw a graph for the probabilities in this continuous data that we're representing, so the graph is somewhat like this. So this is the value that is the median because it is the middle value, it is the mean because it is the most repeated value, has the highest probability, and then lastly it is the mode because it is the mode and it's the median and it's the mean. So in this is called the normal distribution curve, and the area under this curve represents the probability, right? Now how do we represent the normal distribution? So the notations are x follows normal, and the parameters over here are the mean and the standard deviation. The variance. This is the variance. So you represent it with x follows normal, where this is the mean and this is the variance, right? Now there are two types of normal distribution curves. The first is the standard normal distribution, writing ND normal distribution. The second is non-standard normal distribution. So in standard normal distribution, the mean is equals to 0 and the variance is equals to 1, right? So now if I draw the curve for a standard normal distribution, the mean or the median or the mode is 0 and the variance is 1, right? Now over here, for example, we have a value over here that is z. We have to find the probability for z. This is the first case. So we have to find the probability of z, which is a number greater than the mean, right? So probability, and let's say we have to find the probability of values that are less than z, right? So that means that this whole area. Now in MF19 we have this table. Now what does this table represent? So this is the normal curve with a standard normal distribution, and this is z over here. So this table will give us this probability, right? So if z is, for example, 0.4, so the probability is 0.6554, right? That is represented over here by this notation. So our first case is px is less than or equals to z. So that means that we'll find the value for z in the table. That's represented like this, phi z. The second case is if again we have the same the standard normal distribution curve. This is the 0 mean and this is z. Now we have to find the probability of x greater than or equals to z. Right? Now the limitation here is that this table gives us probabilities that are less than z, right? But what we know is that the total probability is equal to 1. So what we can do is we can find the probability of x less than or equals to z and subtract that from 1 to find the probability of x greater than or equals to z. So x greater than or equals to z is 1 minus phi z. Phi z is x less than or equals to z as from the table. Then the third case, again the standard normal distribution curve. This is the mean. Now over here z is negative, or the value, the digit is negative. Now probability of x greater than or equals to negative z. So we have to find this region. Now the second limitation is that this table only gives values of z that are positive and not negative. But the normal distribution graph is symmetric, right? So if z and z are equal, like this z and this z are equal, then this area that is before z will be equal to this area that is after negative z, because it's symmetric, right? So this is equal to phi of just z, positive z. So I'm repeating this because the normal distribution curve is symmetric. So if I had z over here, then this area that I could get from the table using phi z, that would be equal to this shaded area that is greater than or equals to negative z. This was the third case. Then the fourth case, again there's negative z. You have to find the probability of x less than or equal to negative z now. So basically this region. So now, because again it's symmetric, so if I had just positive z over here, then this region would be equal to this region because it's symmetric. So to find this region, what I would do is I'd use this formula, 1 minus phi z. So this will give me this region because it's again symmetric. So these are the first four cases. Now the fifth case is if, for example, I have z1 here and z2 here, and I have to find the probability of x greater than or equal to z1 or less than or equal to z2. So basically I have to find this region. So what I'll do is I'll find the probability of x less than or equal to z2, that will give me this whole region. So phi z2, and then I'll subtract the probability of x less than or equals to z1, that is this region, so I'll get the shaded region. These were the 5 basic cases that we'll be using. Now over here, one more thing to note is that if we had, for example, px is greater than or equals to z, this will be equal to px is greater than z because it's a continuous, the data is continuous over here, so the probability will be the same. So we can use either notation. I'll take some examples so that we understand how to read the table. The first is probability of z less than or equals to 1.361. So this is the first case, right? For example, we have 1.361 over here and we have to find probability of this region, right? So what we'll do is we'll find phi of 1.361, right? So we have to find phi of 1.361. Now 1.361 in the table is, this is 1.3, then this is 6, so that means 0.9131, and then 1.361. So then we'll go into the add column. Over here 1 in front of 1.3 represents 2, so we'll add this 2 to the last digit of this number. So 0.9131 plus 2 will be added to 1, so 0.9133. 0.9133. Then there's p, z is greater than equals to 1.7. This is the second case where x is greater than equals to z. So basically over here we have 1.7, right? So what we'll do is we'll find phi 1.7 and subtract it from 1, because phi 1.7 will give us this area and we have to find this area, so we'll subtract it from the total, that is 1. So 1.7 is right here, and because it's 1.70, so we'll have the first column, so 0.9554. So 1 minus 0.9554, that is equal to 0.0446. Now lastly, there is z is greater than or equals to negative 0.44. This is this case. Yep. So z over here is 0.44. Z is 0.44. So over here we have negative 0.44 and we have to find this area. So we know that the normal curve is symmetric, so we can find the area that is less than or equals to z, that means 0.44, and that will be equal to the shaded area. So we need to find phi of 0.44. So 0.4 is here and then 0.44. So 0.440. So we'll just stop over here. 0.4 and 4, so 0.44, 0.67. 0.67. Those were the standard normal distribution curves. Now non-standard normal distribution. So in non-standard normal distribution, in standard what we had was that x follows normal and the mean was 0 and variance was 1. But now we'll have a mean and variance that are not 0 and 1, right? So what we'll have to do is, because the table in MF19 is only for the normal distribution with mean 0 and 1, variance 1, so we'll have to convert this normal distribution to the standard normal distribution. For that, the formula is that z equals x minus mean upon the standard deviation. This is the variance over here. It's the standard deviation and not the variance, right? So don't write the variance over here by mistake. This is the formula. So we'll do a question. Now over here we have this normal distribution with this mean and this variance. We have to find the probability of x less than equals to 9.7. So before, the normal distribution that is given, it's somewhat like this, and the mean is 6.2. Then we have 9.7. It's after the mean, so 9.7, and we have to find this region, right? So basically we have to find probability of x less than or equals to 9.7. So this will be equal to probability of z less than or equals to, now we'll use this formula, x minus mu upon the standard deviation sigma. So x is 9.7 minus mu, that is 6.2, upon the root of 6.25. So this gives us that we have to find the probability of z less than or equal to 1.4, right? So now if I draw another normal distribution curve, now the mean is 0 because we've converted it to a standard normal distribution. This might be 1.4. We have to find the probability of this region, right? So again, going back to the table, so 1.40, so 0.9192. This is equal to 0.9192. So what we were doing earlier was that we were given the number and we have to find the probability for that value, right? But now we are given a variable as the value and we are given its probability and we have to find that variable. So over here, this is the normal distribution with mean 30 and variance 16. So if I draw the curve, it's 30 mean. Now A has a probability of 0.8944. Now one thing to mention over here, in this curve, because it's symmetric, so the probability till the mean is 0.5 and the probability after the mean is 0.5, right? So because the probability is greater than 0.5, so that means that A is towards the right of the mean. So A might be somewhere over here. Now we have to find the value of A. So what we know is that probability of x less than or equal to A is equal to 0.8944. Now if we convert it to a standard normal distribution, so z is less than or equal to A minus 30 upon root 16 is 4 equals 0.8944, right? So because this is the first case, right, because it's less than or equal to z, so the probability of this is equal to, so basically how we'll deal with it is that we know that at this value, if we go to the table, then we would get this probability. So what we'll do is we'll use this probability to get the value at which we have this probability. We'll equate that with this to find A. So basically what we'll write is, how we'll represent that is A minus 30 upon 4 is equal to phi inverse of 0.8944. So I'm repeating what I just did. So basically we knew that at this value of z, before that the probability is 0.8944, right? So in the table we'll look for this probability and find at which value that probability occurred, and we'll equate that with the value. So this is how we'll represent that value, phi inverse of 0.8944. So 0.8944, we have 0.8 over here, 0.89, 0.8944. So 1.25, 1.2 and 5. So A minus 30 upon 4 equals to 1.25. So A minus 30 equals 5, A equals 35. So there are basically two things that we'll have to mainly do in normal distribution. The first is that we have a value, we have to find the probability for it. Second is that we have the probability, we have to find the value for it. Now moving on to the past papers. So the first question, question 3, the height of sunflowers follow the normal distribution with mean 112 cm and standard deviation 17.2 cm. Find the probability that the height of a randomly chosen flower is greater than 120 cm. So let's take h as the variable, follows normal, 112 cm is the mean and 17.2 square will be the variance, because variance is the square of deviation. You have to find the probability that h is greater than 120, if I'm not wrong. Yep. Now this is a non-standard binomial distribution. Normal distribution. I'll convert it to a standard one. So for that I'll use the formula, z is greater than 120 minus the mean upon the standard deviation. So probability of z greater than this is 0.465. So if I draw a rough sketch of the normal curve, the mean now is 0 because it's a standard one we've taken. You have to find the probability of, okay, so 0.465 will be towards the right because it's positive over here. You have to find the probability of z greater than that, right? So what I can do is I can find the probability of z less than this part, and then subtract that from 1 to get this probability. So to get the probability that is less than 0.465, phi 0.465 will give the probability less than 0.465, and then I'll subtract that from 1 to get the probability greater than that. So at 0.465, 0.4, 6, 0.6772, and then there's 5, 18. So I'll add 18 to the last two digits. So if I add 18 to the last two digits, this will become 0.679. So 1 minus 0.679. So this will be equal to 0.321. That is the first part. Now for the second part, they're saying when a new fertilizer is used, the height of sunflowers follows the normal distribution with mean 115. Now there's a new mean. Given that 80% of the heights are now greater than 103, find the standard deviation. Let's take a new variable x follows normal, 115 is the mean and the standard deviation or the variance is not given. They're saying that probability of x greater than 103 centimeter is 0.80% is 0.8. So x greater than 103 is equals to 0.8, and we have to find the standard deviation. Again, over here we have a non-standard normal distribution. I'll convert it to standard form. So z is greater than x is 103 minus 115 upon the deviation. This is equal to 0.8. Now if I draw the curve roughly, this is going to be 0 because this is a standard normal distribution curve now. Now because let's consider this as a, so the probability of z greater than a is 0.8. So that's why a should be towards the left of 0 because this region will be 0.8, right? Now we have to find what is the value of a first. So if we had to find the probability, if we had a and we had to find the probability of the region greater than a, then what would we would do is that we would look for that we would find phi of a, right? Now what we'll do is that we don't have a, so we'll find the value at which the probability is 0.8. Okay, so the probability is 0.8. Probability is 0.8 at basically this is 0.7995. At 0.84 it's 0.7995. We have to add 5 to it, so 5 is over here at 2, so 0.84 and then 2. So at 0.842 the probability is 0.8, right? Less than the probability of z less than 0.842 is 0.8, means that 0.842 is somewhere over here and this region is 0.8, right? So a will be negative 0.842 because it's towards the left. So that means that 103 minus 115 upon the deviation equals to negative 0.842. So deviation will be negative 0.842. 14.25 or 14.3. Next question, question 21. The random variable x has a normal distribution with mean 4.5. It is given that probability of x greater than 5.5 is equals to 0.0465. Find the standard deviation of x. Okay, so now over here we have x follows normal, where the mean is 4.5 and the variance we don't know, and they're saying that probability of x greater than 5.5 is this 0.0465. Now we have to find the standard deviation. So this is a non-standard normal distribution. I'll convert it to standard form. So probability of z is greater than 5.5 minus the median, that is 4.5, upon the standard deviation, and this probability is equal to 0.465. So if I go into a normal distribution curve, that is standard wala, the mean is 0. So this value will be towards the right of 0 because the probability is less than 0.5. Yeah, probability of z greater than that is less than 0.5, so it will be somewhere over here, this value, right? So the probability of z less than 5.5 minus 4.5, that is basically 1 upon deviation, is equal to, if I take it less than, so that means this region, that is 1 minus 0.0465. So this is equal to 0.9535. So at this value, I'll get 0.9535 as the probability. So what I know is that 1 over deviation equals to phi inverse 0.9535. So I'm finding the value at which the probability was 0.9535. So I'll look for 0.9535 in the table. So here I have 0.9535 right here. This is 1.6 and 1.68. So 1 over standard deviation equals to 1.68. Deviation equals 1 divided by 1.68. That is 0.595. Then in the second part, they're saying find the probability that a random observation of x lies between 3.8 and 4.8. So they're saying find the probability that x is greater than 3.8 but is less than 4.8 in this normal distribution. The normal distribution was that x follows normal and 4.5 is the mean and 0.595 square is the variance. So this is a non-standard normal distribution. I'll convert it to standard form. So z is greater than 3.8 minus the mean, that is 4.5, upon the variance, that is 0.595, and on this side 4.8 minus the mean upon the deviation. So probability minus 1.176 is less than z, which is less than 0.504. Now this is for the standard curve, right? Standard curve mein the mean is 0. Now negative 1.176 will be somewhere over here and 0.504 will be somewhere over here. We have to find this shaded region. So what I'll do is that I'll first find probability of z less than negative 1.176 and then subtract that from the probability of z less than 0.504. Basically this will give me this whole probability till infinity, and then this will give me the probability below negative 1.176, so the difference will give me the shaded region. Now for this probability, this is basically phi of 0.504. Now over here we have to find the values less than that, right? But this is a negative one, so it's not in the table. So how do we deal with that? So basically we know that if we had 1.176 over here, this region would be equal to this region. So how do we find this region? This region is 1 minus phi of 1.176. Phi of 1.176 gives this whole region before 1.176, and then 1 minus gives the region after that, and that is equal to this region. So phi of 0.504. So this is 0.5, then 0, 0.6915, and then 4 is 14. So 0.6915 will add 4 to 5, so 0.6919, and then add 10, 0.6929. So this is 0.6929 minus 1 minus phi of 1.176. So this is 1.1. Then we have to go to 7, 0.8790, and then 6. So 6 is 12. So 0.8790, first I'll add 10 over here, so 0.8800, and then add 2, 0.8802. So 0.6929 minus 1 minus 0.8802 equals 0.577. Now question 26. So the daily minimum temperature in degrees Celsius in January in Ottawa is a random variable with distribution n, that is negative 15.1 as mean and 62 as the variance. And the probability that a randomly chosen day in January in Ottawa has a minimum temperature above 0 degrees Celsius. So we have a normal with negative 15.1 as mean and then 62 as the variance. We have to find the probability that the minimum temperature is above 0 degrees Celsius. So x is greater than 0. Now if x is this is for the non-standard normal distribution. I'll standardize it. So z is greater than 0 minus 15.1 upon root 62. So this means that probability of z greater than 15.1 upon root 62, this is 1.92. So you have to find the probability of this in the standard normal distribution. So that is 1 minus phi of 1.92. So phi of 1.92, 1.9 is over here. This is the column for 2, so 0.9726. 1 minus 0.9726 0.0274. This was the first part. Second part, in another city, the daily minimum temperature in degrees Celsius in January is a random variable with the second normal distribution does not have, the mean is not given, it's unknown. In this city, so the second one, the normal distribution has mean mu and variance 40. Then it's given that probability that a randomly chosen day in January has a minimum temperature above 0 degrees Celsius is 0.48. Okay. So probability of x greater than 0 equals 0.8888. Again, I'll first standardize this because this is the normal, this is the non-standard normal distribution. So z is greater than 0 minus mu upon root 40 is equals to 0.8888. Right. So if I draw the normal distribution curve for this is the mean. Over here it will be 0 because it's standard now, and because the probability of z greater than that is greater than 0.5, right? So this value has to be somewhere over here. And this whole region is 0.8888. Now when I do phi inverse 0.8888, this will give me a value that is, so I look for 0.8888. 0.8888 is 1.22. So 1.22 is basically over here, and this whole region has probability 0.8888. So that means that this, that is A, should be equal to negative 1.22. Negative mu upon root 40 should be equal to negative 1.22. Mu is equals to 7.72. Next is 61. So over here we have a normal distribution. .3 is the mean and 4.5 is the variance. Then they're saying that find the probability that a random chosen value of x lies between 25 and 30. We have to find probability of x greater than 25 but less than 30. So this is non-standard normal distribution. I'll convert it to standard. So probability of z greater than 25 minus the mean, that is 28.3 upon 4.5 ka root, and then over here 30 minus 28.3 upon root 4.5. So 25 minus 28.3 upon root 4.5. So probability minus 1.555 is less than z is less than 0.801. So basically now what I'll do is that let's draw the curve first to better understand it. So the mean is 0 now. Negative 1.55, let's say it's over here. 0.801 is here. We have to find this region. So I'll find the probability of z less than 0.801, subtract the probability of z less than negative 1.555. For this probability, this is phi of 0.801. For this will be equal to the phi of 1 minus the phi of positive 1.555. So phi of 0.801, 0.80, 0.7881, and then we have to add 1. 1 is 3, so 0.7884. Phi of 1.555. So 1.5. Then there is 1.55 and then another 5. So add 5 is 6. So 0.9400. Simplifying this, .72. The next question is question 33. The weight x grams of bars of soap are normally distributed with mean 125 is the mean and variance is 4.2 squared. Now they're saying find the probability that a randomly chosen bar of soap weighs more than 128 grams. So I'll first standardize this. 128 minus the mean upon the deviation. So probability of z greater than 0.714, right? This is equal to 1 minus phi of 0.714. Phi of 0.714, so 0.71 is 0.7611, and then there's 4, that is 12, so we'll add 12 over here, 0.7613 and then 0.7623. So 1 minus 0.7623, this gives 0.2377, that is 0.238. That is the first part. Now part 2, find the value of k such that probability of x greater than k less than 128 is this. .7465. So I'll first standardize this. This is 128 minus 125 on 4.2 that we found earlier, that was 0.714. Now if I draw the normal curve, 0.714 is somewhere here, right? And then if I take this as a could be left of 0 or it could be right of 0 of the mean. We don't know that right now. what we know is that if we find the probability of z less than 0.714 and subtract from that 0.7465, we'll get the probability less than this, right? So probability of z less than 0.714, that is equals to phi 0.714, that is equal to 0.7623. This is the probability of this whole region, right? And 0.7465 is the probability of this bounded by this a. So the probability of z less than a, or that is k minus 125 upon 4.2, this probability is equals to 0.7465 minus 0.7623 minus 0.7465. So this is equal to 0.0158. So probability of z less than a certain value is 0.0158, right? So that means that z has to be towards the left of the mean, that this value, that is a, has to be towards the left of the mean, right? Somewhere over here. So how do we find the probability of how do we find this? So this is basically we know that 0.0158 is this region's probability. So if we had the same value over here, it would be the probability of this region, right? So if we find this, the value over here, will add minus to that and we'll get this value, right? So 0.0158 is this region. So 1 minus 0.0158 is this region. .9842 is this region. So this is equals to phi inverse of 0.9842. This will give us this value, and this will be the negative of that because of symmetry. So negative. So phi inverse 0.9842. 0.9842 is over here, 2.15. So negative 2.15 equals to k minus 125 upon 4.2. So k equals negative 2.15 times 4.2 plus 125. So 115.97. So k equals to 116. That is the second part. Now part 3. So in part 3 they are saying there are 5 bars of soap chosen at random. Find the probability that more than 2 of the bars each weigh more than 128 grams. So probability of x is greater than 128, we know from the first part, is 0.238. 0.238. Now over here, this is a concept of binomial distributions. If you want to revise it, you can watch the video on that. So over here, how did I recognize this as a binomial distribution? That is because there were 5 bars, so there is a fixed number of trials, right? Then there are only 2 groups. This is the probability favorable, 0.238, and then the probability of failure would be 1 minus 0.238, that is 0.762, and the total number of trials is 5. Now they're saying find the probability that more than 2 of the bars each weigh more than 128 grams. So we have to find probability x is greater than 2, right? That is equal to probability of x equals 3 plus probability of x equals 4 plus probability of x equals 5. So 5c3 times 0.762 power 5 minus 3 is 2 times 0.238 power 3 plus 5c4 times 0.762 power 1 times 0.238 power 4 plus 5c5 times 0.762 power 0 times 0.238 power 5. So 5C3 times part 3 next. In part 3, it's saying 5 bars of soap are chosen at random. Find the probability that more than 2 of the bars each weighed more than 128 grams. So probability of x greater than 128 we found in the first part, that was 0.238. Now this is a part of binomial distribution. It's been covered in a previous video, so you can watch that to revise it. So basically how I recognize that it's binomial, that's because there are a fixed number of trials, that are 5. There are only 2 groups, that is success, which is having a weight more than 128, for which the probability was 0.238. Then there's failure, that is having a weight less than 128 grams, so that is 1 minus 0.238, that is 0.762. So these were the criteria for a binomial distribution, so that means that this is binomial. Now since this is binomial and they're saying that there should be more than 2 bars, right? So that means that it's px equals 3 plus probability of x equals 4 plus probability of x equals 5. So for 3, 5c3 times 0.762 power 5 minus 3, that is 2, times 0.238 power 3 plus 5c4 times 0.762 power 5 minus 2 is 1 times 0.238 power 4 plus in the last one 5c5 times 0.762 power 0 times 0.238 power 5. So adding them all up, this is 0.0913. That is the third part.